Okay, as a follow-up to the voltage regulator, Falstad, circuits do they work? Um, which by the way, that original circuit is uh, right in here, an op-amp, so voltage regulator. Um, anyway, I did make a slight modification. I made one of the resistors variable so I could change it like I have here. But here I built one out of their Darlington transistor, just to try it out, and of course it seems to work perfectly. So, um, but I went ahead and put the Darlington transistor back in it. You can see where I have it right now. It's kind of noisy, like, we're putting out, about 8 volts. Where I have it set, I have it, 300, 200 plus 100, so, about 600 ohms. But I'm going to do some, well, let me show you what happens. I'm going to, apply a minimal load to it, and God damn it. Fucking piece of shit. Apply a minimal load to it, and you can see what happens. The voltage goes from, okay, right now it's, 7.8 volts, right around 8 volts, and it jumps up to like 9.2 volts. And that's for me just sticking a very small, like 180 ohm resistor across it, okay? So not significant current. In fact, you can see here what happens current-wise. So it goes from 30 milliamps to 80 milliamps, so it's about a 50 milliamp load. And you see that kind of response. And plus, it's a little noisy, and some of this noise is coming from this because it's actually, a lot more sensitive to noise. That's just me touching my finger to it, right? Okay, so, and another peculiarity I've noticed since I put this back that it wasn't doing before is, I can turn the voltage down below ground reference, and I couldn't do that before. Again, something's really wrong when you can do that. Alright, but let me put it back to where it was for now, and I'll try to set this up where you can kind of watch the voltmeter here. Try to set it up to where you can watch the voltmeter here. As I probe, firstly, the across the Zener diode to show you what one terminal is. Alright, god damn it. Oh, motherfucker. So it's 4.9 volts. Hadn't changed their output much doing that. I probe it. Okay, so it's 3.6 volts, across that lower reference resistor. So, in other words, this is the inverting terminal voltage, 3.6. This is the non-inverting terminal voltage, 4.9. Now watch this. I'm going to stick my negative probe across the Zener diode and my positive probe across the that same second reference, the negative terminal. Okay, it's a 1.7 volt drop. But what you're not seeing is on analog discovery, when I do that, it's jumping from, see, it's currently about 8 volts where I had it set. It's jumping up to 8.5 volts. Almost 8.5 volts, just by me putting my 10 mega ohm multimeter probe across it. Now, my suspicion on this thing, because even when I first read that in Molvino about using this, is like, man, that could be too much gain. the thing is that, a transistor like this, especially driving the kind of load I got hooked to it, requires such minuscule amounts of current. It's being multiplied by an additional 2,000 times, that I think that's within the operating, ends up somewhere in that operating gap between the difference in two terminals. Okay, but this op amp is perfectly happy operating that way. I mean, it's a complete, you know, steady state voltage. In fact, even if I, change the reference, it's quite flat. In fact, you can see, there's about on channel 1 about 94 millivolts, 100 millivolts of noise on it. In fact, it's better, it's very sensitive, again, to me, holding my fingers next to this. You can see just by me bringing my hand next to it, it fluctuates. So that tells me it's an impedance issue, and which is what I was kind of thinking before, but I forgot to mention that in the video, that it had something to do with excessive impedance created by the fact that this Darlington is amplifying this so much for the load we have that, for lack of a better word, it's interacting with the 2 mega ohm input impedance of the op amp, which is supposed to be multiplied and crap like that. But the point is, obviously, putting my little probes across it made a difference in it. So that means 10 mega ohms is a significant amount of resistance to this thing. So, I think it's created such a high impedance circuit that it's just not feeding back properly. In other words, in theory, if I put a more substantial load on this thing, like, I don't know, half an amp or something, which, would probably burn the damn thing out because I don't have any heat sinks on it, and I'm not about to put one in this clusterfuck of a circuit I got built here. That's kind of my basic theory, but I still don't have it nailed down. But anyway, that's all I'm going to do on this for right now, but I just wanted to add that, at least for my own reference, just so I could see, recreate the problem, right, in the future. If this becomes a significant issue, because again, I don't think I'm ever going to build a power supply like this for any good reason. But who knows, right? Again, generally you'd be better off with a 317 in a booster circuit if you needed more current. So anyway, just wanted to make note of that, just for further investigation. So cheers.